Hello everyone, welcome back to my channel Saisha. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we initiated the journey of statistics by understanding some of the basic definitions. In today's video, we will continue the same journey of statistics with few of the concepts like central tendencies. Here we will understand mean, median and mode. Thereafter, we will understand the data distributions using skewness and kurtosis. Now, let us understand the central tendency definitions and types of central tendencies. By definition, central tendency is the central value of the data which is provided to us. Here, there are many types of central tendencies: mean, median and mode. These are the three types of central tendencies which helps us to understand data. Mean. In simple terms, mean means average value of the data set. There are many types of mean. We will understand in the due course of the video. Similarly, median. Median is the middle value of the data arranged in some order. This order might be in ascending order or in a descending order. Mode. Mode is the most frequent occurred value in the data set. Mean and median are the central tendencies which are usually used to understand the numerical data, and similarly mode is used to understand categorical and numerical data. These are some of the types of central tendencies. Now let us understand in brief each type of central tendencies with an example. Now let us understand the concepts of mean. Mean by definition is the average value of the data. There are three types of mean: population mean, sample mean and weighted mean. Population is the entire data values, whereas sample, it is the subset of the population. Here, population mean means the mean of all the values which are present in the population. Sample mean, it is the mean of the sample which we have considered. Population mean is represented by mu. It is a Greek symbol which represents population mean. Here we take the summation of all the values of population from 1 to n. Here n represents the number of values which are present in population. Similarly, in sample mean, n represents the number of values which are present in sample. Sample mean is represented by x bar. Now let us understand with an example. Here we have 6 values: 15, 18, 50, 70, 90 and 95. Sample mean means 15 plus 18 plus 70 plus 50, 90 and 95 divided by the number of elements which are present in the sample. Here 1, 2, 3, 4, 5, 6. There are totally 6 elements. The average value of this sample is nearly equal to 56. This is how we calculate sample mean. Weighted mean. The main difference between the weighted means and the population and sample mean is equal weightage is not provided to all the values, whereas in population mean or sample mean, we provide equal weightages to all the values in the data set. Here, weighted mean is calculated using the formula summation of 1 to n values. Here n represents the number of values present in the weighted mean or the sample data set, and xi represents each value in that sample. Wi represents the weights of each values in the sample divided by the weights. For example, if we consider the marks of the students like 83, 98 and 87, which he has scored in internals, viva and final. But each of the exams has different weightage for the total. That is, internals have 35% weightage, viva has 15% of the weightage and finals has 50% of the weightage. Hence, the weighted mean would be 0.35 into 83 plus 0.15 into 98 plus 0.5 into 87. The whole divided by 0.35 plus 0.15 plus 0.5. Always the weights provided to the each values in the data set adds up to 100. This is nearly equal to 87. This is how we calculate weighted means. These are some of the types of means. Median is the middle value of the data set. The key important thing which we should remember during finding the median value is arrange the data set in an ascending or descending order. Here, let us understand two cases. One, if we have odd number of values and if we have even number of values. This is a data set which is 45, 35, 50, 55, 87, 89 and 92. As this is not arranged in an order, let us arrange it in ascending order. 35, 45, 50, 55, 87, 89 and 92. Median value is the middle value of the data. As you can observe, after 55 there are 3 values, before 55 there are 3 values. Hence 55 is the median value of the data. Similarly, if we have even number of values, then choose the middle two numbers. Example, choose 55 and 50. You can observe 3 values before the 50 and 55 and 3 values after 50 and 55. Now take the average of 50 and 55. 50 plus 55 divided by 2, that is equal to 52.5. In even number of values case, the average of the middle two number provides us the median value. Here for this data set, 52.5 is the average value. This is how the median is calculated. Mode is another type of central tendency to understand data. By definition, the most frequent value in the data represents as mode. When you are identifying mode, you do not need to arrange the data in ascending or descending order. Mode is used to understand data of categorical variables as well as numerical variables. There are 3 types of modes. The data with one mode, that is, in this case here 8 is repeating 2 number of times and 10, 9, 7, 6, 5 are repeating 1 time. Hence, the mode of the data is 8. In this data set, as you can see, there are no frequent values. That is, each value in the data is not repeating. 1, 2, 3, 4, 5, 6, 7, they are repeating only once. Hence, we do not have any mode in the data. In this example, you can see 50 is repeating twice, 55 is repeating twice, and the other values 35, 45 and 70 are repeating once. Hence, we can say we have 2 modes, that is 50 and 55 in the data. This type of data can also be called as bimodal or multimodal data. These are some of the types of modes and identification of the modes using most frequent value in the data set. we have understood the concepts of central tendencies, mean, median and mode. Now let us understand the distribution of data using skewness. By definition, skewness means degree of distortion from normal distribution. Now, what is normal distribution? Normal distribution means the values on the either side of the mean are equally distributed and the values are spread from -3 to +3. We have two types of skewness, positive skewness and negative skewness. Positive skewness means the mean value is greater than median and mode. Negative skewness, the mode value is greater than median and mean. Now let us understand using an example. If you consider the wealth of the Mukesh Ambani and others in the IT industry, then the Mukesh Ambani's wealth will drag the values towards positive. This type of data distribution is called as positively skewed data distribution. Similarly, if you consider the temperature of the poles of the earth and the tropicals, that is, in the poles we have higher negative value temperatures as compared to tropicals, which will drag the values towards negative. This is how we understand skewness of the data. Let us understand the data distribution using kurtosis. Kurtosis describes us the tails of distribution, that is, peakedness of the data and flatness of the data. The mesocuratic or the normally distributed data is represented with the curatic value equal to 3, that is, the distribution of the values are between -3 to +3. The kleptocuratic, the kurtosis value is less than 3, which means we have the tail values lesser than the normal distribution and the peakedness is higher than the normal distribution. For example, in the past decade, the population of India had higher number of younger generation as compared to the younger and elderly people. Similarly, in plantocuratic, the kurtosis value is greater than 3. That is, distribution values are greater than -3 to +3 and the peak of plantocuratic type of distribution is lesser than the normal distribution. For example, if you consider in the past decade, the population of China, the elderly people was higher as compared to younger and infants. This is how we analyze the outliers in the data using kurtosis. If you like my video, please like, share, comment and subscribe my channel. Thank you.